Hello and welcome to another episode of James Dean Designs, where today we are taking a look at the latest feature in Carveco Maker, the 4th axis rotary device. Now, as a reminder, this is part of an entire beginner series and all the previous episodes can be found in the corner where we go through a lot of basics to get you up and running in the software. Now, there's one thing I'm going to mention before we really dive into this tutorial. Everything you can do in Carveco Maker can be applied to the rotary function, but for today's episode we're just going to look at some of the basic drawing tools and features, applying it to that rotary function. But if you want to see things like 3D reliefs being applied, then check out Leighton's tutorial in the corner where he shows you how that can be done. Now, the tutorial itself, what we're effectively going to do is look at ways of applying some designs to this piece of material. This is 100mm long, 35mm in diameter. But the crucial thing is, don't imagine it that we are applying designs to a cylinder. What's actually happening is we are applying designs to a flat surface like we normally would within Carveco Maker. And then that design gets wrapped around the cylindrical shape to give our output. So I'm just mentioning that first, and you'll see it come to life as we go through the tutorial. But let's move over and start to dive in. So in Carveco Maker, the first thing we would usually do is select new model, but today we need to go up to File, then select New and Rotary Model, and we get this new dialog box. Now, whilst it is fairly self-explanatory, there are a few things I need to clarify. We'll see here it says cylinder dimensions. This is quite crucial. Carveco Maker can only calculate for cylindrical objects. So for example, it cannot calculate for you putting square stock into your rotary device or rectangular stock in there either. It can only use cylinder material, or cylindrical materials I should say. Now, the diameter of my wood today is 35mm. The length of it is actually 100mm, but because part of it is being held within the chuck, I've taken it down to 80mm just to allow for that. Now, on the rotary axis, the easiest way to think of this is effectively which direction you want your router or spindle to move whilst machining. 99% of the time this is going to be x-axis, which is left to right, because your 4th axis or your rotary device will usually sit horizontal with your x-axis, but you do have the option to make it the y-axis should you want to. Units is self-explanatory. I'm a metric man, so will remain on millimeters, and resolution I always keep as high as possible. So let's click OK and generate our work area. Now, you may have seen for a very split second then it flashed up as a flat piece and then changed to a cylinder object. Now, as I mentioned at the start of the video, the easiest way to think about this is you're not technically working on a cylinder, you are working on a flat plane being wrapped around a cylinder. Now, we have this orange button going on over the right hand side, which I say is new in Carveco Maker, and this toggles between the flat view and the rotary view. So if I click this now, you can understand what is going on. Flat view, back to rotary view, and as we work through, you will just understand the way it calculates and develops the toolpaths around this. Now, before moving on, I'm just going to quickly point out one other thing. You may be familiar with this 3-axis origin feature going on in the middle. This is usually where your calculations will start from in terms of generating your toolpaths. But if I rotate this around, what we will actually see, it is in the dead center of the material. Now, if we quickly switch to another project, what we can see is normally you would have this origin feature on top of your material because it's calculating where it's starting the jobs from. But in the cylindrical or rotary view, it actually has it in the dead center of the material. Now, it's impossible to try and set your Z height to the center of that material. But what Carveco Maker actually does when it generates the toolpaths is it features in an allowance to actually make it start from the top of your material. We will see this in better detail very shortly when I generate a simulation, but don't worry about that too much for now, because as I say, Carveco Maker does all the hard work for you to set it to the top of your material. Now, let's put this back to the flat view, and we'll also reset the view itself. Now, I'm going to jump over to the 2D view mode purely because I find it slightly easier to work on this white background. The first example we're going to do is come over to the text feature. I'm going to click in the middle of the canvas and simply type Carveco. Now I'm going to click create to make that permanent and hit F9 to put it in the middle of our canvas area. Now I'm going to run through the toolpaths fairly quickly because this tutorial is not about the actual toolpaths themselves. It is about understanding the rotary feature and some of the things you can do with it just using basic 2D tools. So let's go to toolpaths and we're going to use the V-carve feature for this one. And what we want to do is use selected vectors, start depth of 0, which is obviously the top of our material. We've got a maximum depth of 10, but to be honest with you, I don't think we'll even get that deep. So we'll come to carving tool, and I just want to use something like a fairly generic 90-degree V-bit. So if we extend our V-bit menu out, select that one, click select. Now what you can do at this point obviously is generate the maximum width and depth that it is going to cut, and we can see there, yeah, it's not even machining a depth of 1 millimeter deep, just under. So that's ideal for this project. Don't need a roughing tool because it's a fairly light carving. Our options are already set for the safe height and the home position. This has a Z safe height of 5 millimeters, and I'll show you this in position very shortly. But we do need to define the material itself. Now the important part here is the material thickness should be half of your diameter. So actually it needs to be the radius, not the diameter. My material is 35 millimeters in diameter, so it actually needs to be 17.5, which is half of 35. The material Z0 should be set at the top, and your top offset should be 0, so we can click OK, and that is now factoring the material as part of this. For the toolpath name, let's just call this text, and we'll click calculate now. Obviously the red lines appear, those are our toolpaths that we have generated. But if we switch over to the 3D view, what we can now see that we didn't see earlier is this big shaded area in the middle. And if I start to rotate this around, you'll understand what's going on. So whilst we are designing and our vectors are on a flat plane, the toolpaths are actually being generated to the outside of the cylinder that we are working with. And you can switch between, as I say, the rotary view and the flat view. You can still see the toolpath working there basically just below the surface of the cylinder itself. But what we can also do is we're going to go into the toolpath menu, right click on our toolpath and simulate with control bar. Now I mentioned earlier about Carveco Maker offsetting the origin to start above your material, and if I rotate this around you'll start to see what I am talking about. Whilst the origin is in the dead center of the material, this is actually starting above the material with our safe 5 millimeter height factored in already. So as I say, it does the hard work for you in calculating all of this. If I rotate this back just a little bit and we will run the simulation, we get an idea of what is actually going on and the way it carves around the curve of the shape itself. So whilst that is a very simple demonstration, it starts to give you an idea of how it works. And what we can actually do is maybe select that tool again, hit text T, rotate this around 90 degrees. If you hold the Alt key, it will rotate it at set increments, and we'll just recalculate those toolpaths now. If we go in and then essentially re-simulate that, we can see it's now wrapped the text around the body of the cylinder itself. And this is basically, just another different way you can use the text on this cylinder feature or this rotary function. But let's do something a little bit more interesting. We'll delete that out the way. We'll also delete all the toolpaths and effectively just go back to starting from scratch. Now I'm going to bring in a little bit of a vector that I've designed, just dragging this in off my other screen. I have a feeling this is, yeah, there it is. It's put it down in a random position. So what I'm going to simply do is hit F9, get all these back in the center of the canvas area. Now, when I mentioned earlier about this wrapping around the cylinder, if you want something to go all the way around, then obviously it needs to touch the top and the bottom itself. And we will see in this demonstration here. So I've hit T again. I'm just going to drag this right to the top. I'm also going to drag it right to the bottom as well, just so it is literally touching top to bottom, edge to edge. Now I'm just going to use a profiling tool at this stage. So back up to toolpaths, select the profiling tool. We want it to run along the line itself, and let's have a finishing depth of maybe 5 millimeters. We'll just use a very simple tool such as a 1/8 end mill, or there we are, a 3.175 end mill, also known as a 1/8 end mill. We can ignore all of the rest of the settings, and as I say, all the standard settings for the bits will remain, because this is purely about showing the rotary function within Carveco. The material thickness has already been set, so all we need to do now is give this a name. Let's call it waves. So if we click calculate now, and we will run the simulation for this. And now we can see from what is a fairly simple design of a few wavy lines, you start to get a really cool feature going on in the actual cylindrical design. Now, if I rotate this round, hopefully you can just about see that line appearing on the screen. That is effectively the start and end of your canvas area, where it wraps around and meets each other. Every time I release the mouse, it does disappear, so it's kind of hard to show, but hopefully you can see it. And when we actually zoom in, obviously these meet perfectly because of the way the design is done. If I actually stand this up, it kind of looks cool. I know it sounds silly, but I feel that this actually just looks much better when it is up vertical and being rotated than on its side. Let's have some more fun with this. I'm going to go back to the 2D view just to make sure they are selected. We are going to use the profile toolpath again over this same carve, but instead we are going to do something just a little bit different. We're going to run it along the lines again. We're going to have a finished depth of, let's make it 6 millimeters. Select the profiling tool. Let's use a V carve. Let's use the same V bit that we used earlier, a 1/4 inch V bit. And let's just call this V waves. And if we calculate that, so effectively what it's doing now is using two tools. It's going to use the flat end mill to machine them out first, then it's going to use the V bit over the top, and we should see hopefully quite a cool simulation going on when I generate this. There we have it. So from two simple tools and basically one set of simple toolpaths, you can really generate some cool 3D designs on your cylindrical objects, and that does look awesome. Now, what people sometimes like to do on rotary devices is cut the ends off their design. So if you imagine when you are cutting things out of of your material, normally when it's flat, you would leave tabs on your material to hold it in place. Now we can do the same with that, but we have to generate the tabs ourselves, kind of in a bit of a fake way, but it just means that we can have nice, crisp, clean ends on the ends of our cylinders. So what we're going to do is let's come back to the 2D view. We're going to just deselect everything, and we're going to come over to the poly line. We're going to start just off the top of the material up here to the left. We're going to select, we're going to draw a straight line all the way down. If you hold down shift, it should draw a straight line and come down to the bottom of the material. We'll then unselect and just end the line. We're going to copy and paste this, Control C, Control V, and just drag the duplicate over to the side. Holding Alt down will keep it in a horizontal position in alignment to the first one that we created. Now if we select both of these, and what we're going to do is use the profile tool again, but what we're just going to use the end mill to go a little bit deeper this time and effectively create two fake tabs on the start and end of our cylinder. So we'll select along again. We're going to have a finished depth. Now the half of the depth obviously is 17.5, so if we left it at 17.5, it would cut all the way through our material as it rotates. So we need to make this a little bit less, maybe 15 millimeters, and that should in theory then leave a 5 millimeter piece holding the cylinder in position. So let's just use the 1/8 end mill that we selected earlier. There we are. Click select, and again leave all the standard settings in for that particular bit, and we will call these the tabs. So if we generate those now, and if we go back and resimulate all of this, what we can see is we have our pretty cool design going on in the middle here, but what we actually have now is two fresh cuts on either end of the cylinder, so that when you take this out of your rotary device, you can simply cut those off with a trim saw, something like that, and have a very nice finished piece as a result of adding those fake tabs in. So we've quickly done two projects. Let's just do a third one to finish this up. 3 is a nice number to work with. Let's delete everything back out again, go to a blank canvas with no toolpath. So what I'm going to do is come over to the rectangle tool. I'm going to start above the material itself. I'm just going to drag all the way down to the bottom left of the material, and place that there like that. The width of this, let's just make it around 70 millimeters. Now in terms of the height of this, it doesn't really matter because I want it to go all the way around. It just needs to extend quite a bit above the material top and the bottom itself. We'll leave the corner radius as 0 and we'll leave everything else as it is. Click create. And now what we're going to do is use the area clearance tool to basically take a block of material all the way off around the cylinder itself. So we select area clearance tool. We're going to leave the start depth as 0 and have the finish depth as 5 millimeters. Now if I come down a little bit, what I just want to do is select a fairly big end mill just to speed this up. Maybe an up, there we are, 1/4 inch upcut flat end mill. I'm going to select that, leave all the standard settings in place as I purely for demonstration purposes, and we're going to leave it on the raster strategy as well. Let's give this a name of block. And click create now or calculate now. Now what we can see, obviously it's put all the tool lines in there, but I'm just going to turn this off for a moment just to make visibility slightly easier for us. Now I'm going to leave the rectangle tool selected that we've got, and I'm just going to come back up towards this top left hand corner and draw another rectangle inside of that. Now in the tool settings menu, if you don't see it, you obviously just switch to the tab over in the bottom right hand corner to bring all your tool settings back up. Now I'm going to make this 60 millimeters wide, 7 millimeters high, and let's give it a corner radius of just under half, so let's make that 3 millimeters. I'm going to click create. Now what I want to do is repeat this a few times below to fill the rest of this canvas space up. So we're going to use the block copy feature. Now obviously you can block copy or you can rotate and copy. Block copy is what I need for this instance, and it's remembering my settings from when I tested this earlier. So I'm not just fortunate and it's perfect already, as I did test it before doing this, but we do need to change some. So I wanted to repeat the ovals below it, not above it. So we're going to change this arrow here to point downwards. And what this is effectively doing is producing 10 rows of this in one single column. So when I click apply, there we are, we've got 10 variations now, all below each other with the relevant offsets that we set as part of this feature. So if we go back to the arrows, what I want to do is just make sure these are sitting in the collection is sitting in the center of the canvas. So again, just hit F9 and make sure they are all perfectly offset. Now I'm going to use the area clearance tool again, but I'm going to use a ball nose this time. Now for the start depth, obviously we have just technically taken 5 millimeters off the outside of the cylinder, so this can start a little bit lower. So we'll put the start depth at 5 millimeters and we'll put the finish depth at 9 millimeters. So that should mean that it's going to machine 4 millimeters deep for each one of these ovals. Now in terms of the tool, I want to use a ball nose for this. So if we head into the tool menu and just find a ball nose somewhere, 1/4 inch diameter ball nose, there is perfect. Select that. Again, leave all the settings as standard. Raster option is fine, and we will call this ovals. Let's generate those now. And what we can see is if we generate this as a simulation, very simple, but a couple of shapes and we get this kind of Roman column Colosseum thing going on. So yeah, that just gives you a bit of a roundup of what you can do with some very basic 2D drawing tools and some very basic cutting tools to get some pretty cool features as using this part of this rotary tool that Carveco have now introduced into Maker, which I absolutely love. So to finish up this tutorial, I'm going to show you how to export the toolpaths because there is a slight setting that you need to change. So in the Save Toolpath area, what we can see down here in the machine file format is we expand this out and you have lots of different options in there. Now as we can typically see, I normally use Gerbil millimeters. This is my standard post processor that I use all of the time. But when we open this menu up, we can often see rotary variations. So here we have Haas rotary, and if, for example, if we scroll down to the Mac area, you will see there is also like a Mac rotary option as well. Now this is the same with Gerbil. The problem is at the point of doing this video, Carveco have not included the Gerbil post processor as part of their update. So what we can do is add these manually into our post processor menu in order to get them in there. Now to do this, there will be a link in the description area below the video to download Gerbil millimeter rotary and Gerbil millimeter Gerbil inch rotary as well. These two files here. Once you've downloaded them, head over to this folder. It is called C Drive Program Files Carveco postp. This is where all of your post processors are stored, and simply copy and paste those two files that you've just downloaded into this folder here, like you can see on screen: Gerbil inch rotary, Gerbil millimeter rotary. It may ask you for admin permissions. Just click continue and paste them in. Once they are in this folder, restart Carveco, and then you can come back to your machine file format menu, expand it out, and they will be in that menu like they are here. Simply select the one that you need, and then you can save your files out as you normally would, but with the rotary format included. So hopefully that gives you a good understanding of how the rotary function now works within Carveco Maker. As the series goes on, I will be doing further follow-ups on this and maybe incorporating 3D reliefs as well. Hopefully you found this video useful. If you did, please give it a thumbs up and make sure you subscribe if not done so already. Thank you very much for watching the video, and as always, final thanks goes to my patrons. If you want to get involved for one-to-one help, early access to content and even giveaways, then check out the Patreon links in the description area below. I'll see everyone on the next episode.